Today we're going to be looking at an example where we take two functions and we do operations with them. So like we add them together, we subtract them, multiply, and divide. Okay, so let's say I have two functions, f of x and g of x. So if I wanted to add them together, I'd be finding the new function f plus g of x that is going to equal f of x plus g of x. Okay, so we call this a sum. The difference would be f minus g of x. So we're going to take f of x and we're going to subtract g of x from it. We can also find the product. So f times g of x is equal to f of x times g of x, and the quotient, f divided by g of x is equal to f of x divided by g of x. Okay, so we're going to look at an example. We're going to go through, we're going to find all four of these new functions, and then we're going to evaluate. Given an x value, what would the result be? Okay. So let's say I'm giving the equations f of x equals 2x plus 1 and g of x equals 3x minus 5. Okay, so the sum. We said that f plus g of x is equal to f of x plus g of x. Okay, so f plus g of x equals 2x plus 1 plus 3x minus 5. Okay, I went ahead and plugged my equations in for my function notation, but you'll notice I put them both in parentheses. Okay, I don't have anything multiplied to the front of these parentheses. I have a plus sign in between them, so I don't have to distribute anything over. So I don't actually need the parentheses. So I'm fine to say that this is 2x plus 1 plus 3x minus 5. And now all I have left to do is combine my like terms. So 2x plus 3x gives me 5x. 1 minus 5 gives me minus 4. So f plus g of x is equal to 5x minus 4. Now let's say we want to evaluate f plus g of 1. Well, I'm going to do what I would normally do. I'm going to take my 1 and I'm going to plug it in everywhere I see an x. So that is equal to 5 times 1 minus 4. 5 times 1 is just 5 minus 4. And 5 minus 4 is just 1. Okay. Let's also talk about the domain here really quickly. Now, my original two functions were linear. There's nothing I can plug in here that is going to give me something undefined or imaginary. So my domain here for these two is all real numbers. Now that I've added them together, though I'm still left with something linear, I'm still not going to get anything imaginary or anything undefined. So my domain remains all real numbers here. So my domain is all real numbers. But remember, you might see the double R. Let's find the difference. We said that f minus g of x equals f of x minus g of x. Okay, so plugging in my two equations, I have 2x plus 1 minus 3x minus 5. Okay, so I plugged in my equations for my function notation here. Once again, I don't really need this first set of parentheses, but on the second, I have a minus sign in between them. That means I need to distribute the negative across this set of parentheses. Okay, so I have 2x plus 1 minus 3x plus 5. Remember, once you distribute this over, all of your signs change. Okay. And once again here, I'm still left having to combine my like terms. I have 2x minus 3x. That's going to give me negative x. And then 1 plus 5 gives me 6. Before we evaluate, again, let's talk about our domain. My original two equations were linear. Their domain is all real numbers. Here, once again, I'm left with something that's linear, so I'm not going to get a value that's undefined or imaginary. So we're good. So my domain here, once again, is all real numbers. So now let's evaluate. Let's find f minus g of 1. Okay. So f minus g of 1, I know my equation for f minus g, so I just have to plug 1 in here for x. So I've got negative 1 plus 6. That is negative 1 plus 6. And negative 1 plus 6 gives me 5. So we found the sum and the difference. Next, let's find the product. So we want to find f times g of x, and we said that was f of x times g of x. Okay. So f times g of x, right here, we've got 2x plus 1 for f of x times g of x, which is 3x minus 5. Okay, so here I have my two sets of parentheses, but I need to multiply them together, so I need to FOIL it in order to clear my parentheses. Okay, so 2x times 3x gives me 6x squared. 2x times negative 5 gives me negative 10x. 1 times 3x gives me plus 3x, and then positive 1 times negative 5 gives me negative 5. So combining my like terms, my negative 10x and my 3x, I get 6x squared minus 7x minus 5. Okay. So domain. I cannot pick a number and plug it in for x, a real number and plug it in for x, and get anything that is imaginary or undefined. So my domain here remains all real numbers. Okay, let's evaluate f times g of x of 1. So we know f times g of x, the equation is right here. So all I have to do is take 1 and plug it in everywhere I see x. So I have 6 times 1 squared minus 7 times 1 minus 5. Okay. 1 squared is 1. 6 times 1 is 6. 7 times 1 is minus 7 minus 5. Okay, so 6 minus 7, that gives me negative 1 minus 5. Negative 1 minus 5 gives me negative 6. Okay. And finally, let's find the quotient. So we said that was f divided by g of x. So we're looking for f of x divided by g of x. F of x, we said, is 2x plus 1 divided by g of x, which is 3x minus 5. I plugged them in using parentheses, but as you can see, I don't have any negative signs out front to deal with. So I'm fine to just drop them and rewrite it as 2x plus 1 over 3x minus 5. Okay, so right here, this is fully simplified. So here, my domain, I don't have a square root, so I'm really not concerned with imaginary, but I did end up with a function that was rational. And so I am very concerned with ending up with something that's undefined, which means I don't want 0 in my denominator. So I'm going to take 3x minus 5 and set it not equal to 0. Adding 5 to both sides gives me 3x cannot equal positive 5. Dividing both sides by 3, I'm left with x cannot equal 5/3. Okay, so my domain here is x such that x cannot equal 5/3. Make sure you put those in braces. And now to evaluate. I'm fine to evaluate this as long as I do not pick 5/3. So let's do f divided by g of 1. Okay, so I know f divided by g is right here. So all I have to do is plug in 1 everywhere I see an x. So I'm looking at 2 times 1 plus 1 divided by 3 times 1 minus 5. Okay, 2 times 1 is 2, so I'm at 2 plus 1 in the numerator. 3 times 1 is 3, so I've got 3 minus 5 in the denominator. 2 plus 1 is 3. 3 minus 5 is negative 2, so I'm at negative 3/2. And I'm done.